Imagine the ultimate cosmic magic trick, pulling solid, physical matter out of thin air, using absolutely nothing but pure, weightless light. Sounds like something out of a sci-fi movie, right? I mean, we're so used to thinking of light as just an intangible beam. It's a way to see things, not something you can actually hold in your hand. But today, we're diving straight into a mind-bending reality where pure energy is literally transformed into physical substance.
The fundamental question we're exploring in this explainer is exactly this. Can you smash light together to create solid matter? Our everyday intuition tells us that light is just a wave of illumination. If you shine two flashlights at each other, the beams just pass right through one another. Nothing crashes, nothing shatters. But what if you could force those light particles, called photons, to hit each other with such unimaginable energy that they actually birth solid particles into existence?
Part 1. The scientific problem.
Okay, so back in the early days of quantum physics, scientists figured out that when matter and antimatter collide, like an electron and a positron, they annihilate each other in a massive flash of light. Well, in 1934, two brilliant physicists named Gregory Breit and John Wheeler proposed that if the universe has a fundamental symmetry to it, the exact reverse must theoretically be true. Light should be able to collide to create matter. This became known as the Breit-Wheeler process. But here is the crazy part. There was a massive 80-year gap between the theory and the actual experiments. The idea basically sat unproven for decades because humanity simply lacked the technology to smash light quanta together hard enough. We just didn't have light sources powerful enough to make light behave like colliding billiard balls.
In fact, in their 1934 paper, the theorists themselves wrote, "An experimental observation of the process is hopeless." They literally believed it was technologically impossible to prove in a lab. And you can see why. To create matter from a massless state, you need an incredibly dense concentration of gamma-ray photons, light that is billions of times more energetic than the visible light we see. Producing a significant number of these matter pairs requires extremely bright, highly focused sources of photons. So, for decades, it seemed like a totally impossible dream.
Part 2. Smashing light with lasers.
Eventually, that theoretical hopelessness gave way to extreme, high-intensity laser engineering, all aimed at turning pure light into solid matter. In 2014, researchers at Imperial College London proposed a genius setup. Think of it like crashing two incredibly powerful waves of light together inside a tiny, empty gold room. First, they proposed firing an extremely powerful laser at a slab of gold to create a beam of high-energy photons. Second, they'd use another laser to heat the inside of a tiny gold can called a holoraum, which is literally German for empty room, creating a really dense bath of thermal radiation. Finally, you direct that first beam of photons right through the center of that tiny gold room. The light sources collide, and out pops physical matter, electrons and positrons.
Now, before that specific holoraum idea came along, a monumental milestone was actually achieved back in 1997. In a landmark paper from the Stanford Linear Accelerator Center, or SLAC, scientists managed to use high-energy electrons and a powerful terawatt laser to generate a multi-photon version of this matter creation process. They didn't just smash two single photons together. They smashed a high-energy photon into a dense laser field, creating over 100 positrons. This was huge. It was the first laboratory evidence of inelastic light-by-light scattering. They successfully proved that light, under incredibly extreme conditions, can indeed birth matter.
Part 3. Matter from the vacuum. But scientists still wanted the holy grail, the pure, linear Breit-Wheeler process. Just two individual particles of light colliding to create a pair of matter and antimatter particles in a single, elegant step. That definitive breakthrough finally happened in 2021 at the Relativistic Heavy Ion Collider, or RHIC. Here is what they did in super simple terms. They took heavy gold ions and accelerated them in opposite directions to 99.995% the speed of light. Now, they didn't crash these ions into each other. Instead, they orchestrated a near miss. Because these gold ions carry a massive positive charge and are moving so unbelievably fast, they generate a spiraling magnetic and electric field of immense power. In physics, when an electric and magnetic field are of equal strength and moving at light speed, that is the literal definition of a photon, a particle of light. So, as the gold ions sped past each other, their surrounding clouds of photons collided. And the result? They detected thousands of pure electron-positron pairs. Real matter and antimatter, created purely from the interacting light fields of the passing ions.
And here's the thing, this isn't just a neat laboratory trick. When we look out at the cosmic microwave background, that ancient radiation left over from the Big Bang,
We realize this exact light-smashing process happens naturally out there in deep space. Pair production mirrors cosmic processes occurring in the deepest, most extreme corners of the universe, essentially acting like a giant particle collider.
In fact, the Breit-Wheeler process basically regulates the high-energy universe. It acts as a cosmic speed limit, or what astrophysicists call a gamma-ray horizon. When incredibly powerful events like black hole collisions emit ultra-high-energy gamma rays, those rays travel through space. If they bump into the low-energy photons floating around in the cosmic background, they collide and instantly turn into matter. This literally absorbs the high-energy light in the universe, shaping the environment in distant regions of space around faraway galaxies and gamma-ray bursts. Without this light interaction, the sky would look completely different to our telescopes.
Part 4. The fabric of reality. When we realize we can pull matter straight from light, we are really forced to rethink what stuff actually is. To understand this, we need to redefine reality through the lens of quantum field theory. According to this framework, space is not empty. There is literally no such thing as a true void. Instead, the universe is filled with invisible quantum fields representing pure potential rather than solid objects. Think of these fields as a completely still, invisible ocean covering all of space. What we casually call a particle, whether it's a particle of light or a solid electron, is simply a localized excitation. It's just a temporary ripple in that specific field.
This forces a massive, fundamental shift in how we view the universe. In the classical view, we imagine the universe built out of solid, hard billiard balls. Matter is matter and light is light. But the quantum reality shows us a dynamic fabric where quantum fields act as an underlying foundation of reality. When those two photons collided in the RHIC experiment, the energy from the light field ripples was simply transferred into the electron field, causing a new ripple to pop up. Energy and mass fluidly trade places. It is all the exact same underlying ocean, just different waves.
Pulling matter from light completely shatters the boundary between energy and substance. It proves they are completely interchangeable. Mass and charge aren't necessarily hard, permanent substances. They are just properties that emerge based on how energy is physically organized at a specific moment in time. The Breit-Wheeler process is the ultimate proof that you can pour pure energy into the vacuum, and the universe will seamlessly organize it into solid mass.
Part 5. Are we just ripples?
So, if solid matter is just a temporary ripple in an invisible field, what is the true nature of our physical existence? The atoms that make up your body, the chair you're sitting on, the device you're watching this on right now, they are all born from the exact same dynamic quantum fields that scientists just sparked into life using pure light. We are not made of static, hard matter. We are highly organized patterns of energy, shimmering in an invisible quantum ocean. It took 80 long years to prove Gregory Breit and John Wheeler right, but in doing so, science hasn't just shown us a neat trick. It has revealed the profound, fluid, and brilliantly interconnected physical fabric of our reality.